Some friends and students helped me come up with this. NWIRI. This is what it means. Nobody wants irresponsible raccoons indoors. That's one. Or you could do never walk inside rainy igloos. Or you could do Norman wears itchy rainbow insoles. Or finally you could do natural, whole, integers, rational, irrational. That's what I really want to show you. Let's get started with our presentation. So natural numbers are your counting numbers. 1, 2, 3, so on and so forth. Whole numbers are natural numbers plus 0. When would you use whole numbers? When you need a 0. 5 minus 5 equals 0, so use whole numbers. NWI, the first I is for integers. Integers are whole numbers and their opposites. So -3, -2, -1, 0, 1, 2, 3, continue on. Continue in both directions, both positive and negative. Integers will show you a negative temperature, a loss of yardage in a football game, a negative bank account. After integers, we have rational numbers. The rational numbers are easy to remember if you just remember the word ratio. The first ratio to remember is 1/4. It's a good example of a rational number. This fraction is easily converted to a decimal, and this decimal terminates. When a decimal terminates, it's a rational number. This fraction converts to a decimal that repeats. When a decimal repeats, it's also a rational number. It comes from a ratio. A ratio is a comparison of two integers by division. This is a division sign right here. Next, and finally in this presentation of our real numbers, we have irrational numbers. Irrational numbers are decimals that do not repeat, they do not terminate. When you think of pi, you think of 3.14, but don't forget that pi continues on and on. It doesn't repeat numbers in sequence, and it doesn't terminate. It's amazing. You use pi when you're working with circles. Pi is the ratio of the circumference of a circle to the diameter of a circle. Another example of an irrational number could be used when you're working with triangles. This triangle, for instance, has a side with a length of 1, another side with a length of 1. The hypotenuse will have the square root of 2. If you put this in your calculator, square root of 2, you will see that it's a decimal that does not repeat or terminate. This is a presentation about the real numbers. Natural counting numbers, whole numbers that include 0, integers with both positive and negative, rational numbers with ratios in the form of fractions and decimals that terminate and repeat. Irrational numbers are decimals that continue, they don't terminate, and they don't repeat. Square root of 2 for triangles, pi for circles.